Hello, my friends. There are two types of people in this world. Those who can extrapolate from incomplete data. Anyway, in this problem we're going to try direct substitution. So I plug in 1, I get 1 to the 4th minus 1 over 1 minus 1, 0 over 0. That is not undefined. That's an indeterminate form. So I've got to do something to try to make this work. Looks like factoring probably works because I see a difference of squares on top. X squared plus 1, x squared minus 1. And I could go further with that because I see another difference of squares within there. So I still got my x squared plus 1, then my x plus 1, x minus 1. The denominator is not a difference of squares, but it is a difference of cubes. If you don't remember how to factor a difference of cubes, you should definitely check up on that. We get something like this. And we are going to see here that something cancels out. Hopefully that makes the problem not broken anymore. Cancel out my x minus 1s. And it's time to plug 1 in again and see what happens. So plugging 1 to the top, it looks like I get 1 squared plus 1 times 1 plus 1 divided by 1 squared plus 1 plus 1. 2 times 2 is 4 over 3. Taking a look at my answer choices, I see 4 over 3, and that's it. In this next problem, I can try plugging in pi. So I'd get something like pi times sine of pi squared over cosine squared pi minus 1. I think this is going to give us a problem because we end up with 0 over 0. So we have to try stuff. I notice that I see the Pythagorean identity kind of show up in this problem. Sine squared x plus cosine squared x equals 1. I can change that sine squared x to negative cosine squared x plus 1. Notice this almost looks like the denominator. I need to factor out a negative 1 now. So I can say negative sine squared x equals cosine squared x minus 1. This now exactly matches with the denominator. So I'm going to rewrite this problem, leaving the top the same, divided by, I'm changing the bottom from cosine x squared minus 1 to negative sine squared x. Doing so lets me reduce. I'm left with basically just negative x. I can now try to plug in pi again, and I get negative pi, which is answer choice C. In this problem, we're trying to find out when the limit as x approaches 1 does not exist. So I'm just going to look at each graph separately. On graph number 1, I see that the limit from the left and right are both negative infinity. But negative infinity is just another way of saying does not exist. So I know graph 1 works, which means choice B and choice C already gone. I look at part 2, limit from the left and right are also both negative infinity, or DNE, which means that graph 2 also works. At this point, I don't even have to worry about graph 3, but for the sake of completion, we should maybe verify. I look at the limit from the left, and it looks like I get negative 3. I look at the limit on the right, and it looks like I also get negative 3. I don't care at all that the dot is at y equals negative 1. That's irrelevant. For limits, I don't care about where the dot is. I care about where the graph is getting close to on the left and the right. So this limit exists. 3 is gone, which leaves us with choice D. This one looks a little tricky with the algebra and the trigonometry, but I'm looking for a value of k that makes the limit equal the function value. So let's take a look at this. The limit as x approaches 1 means I want to look to the left of 1 and to the right of 1. In both of those cases, I'm going to use this guy because it says use the top equation whenever x does not equal 1. That includes the left of 1, like 0.9, and the right of 1, like 1.1. So let's plug 1 into that and see what happens. If I plug 1 into the top, I get 2 times 1 squared minus 5 times 1 plus 3 over 1 minus 1. Looks like I end up with 0 over 0. That's a problem. That's an indeterminate form. So I'm going to factor the top using Clinton magic. Looking for two numbers that multiply to give 6, add to give negative 5. I think the winners are negative 2 and negative 3. So it looks like as I reduce, I get my factors, 2x minus 3, x minus 1 over x minus 1. Another clue that we would have gotten x minus 1 on top is the fact that x minus 1 was on the bottom. That means it was probably going to be on the top too, so something would cancel. Try plugging 1 into this again, and we'll get 2 times 1 minus 3 equals negative 1. So we found out the limit value as x approaches 1 is negative 1. Now we have to figure out what f of 1 is. And for exactly 1, we don't want to look at the top equation, we want to look at the bottom. It says to use that guy whenever x is equal to 1. So I'm going to plug in 1 for x, but I notice there's no x to plug into. But I do know I want this to equal negative 1, so that it matches up with my limit value. Looking at my answer choices, I'm just going to try them. I know sine of pi over 2 is going to give me 1 plus cosine of pi over 2 is 0 equals 1. Nope, that didn't work. So let's try pi, which is our second choice. Sine of pi is 0. Cosine of pi is negative 1. That worked. So we might just have 2. We might also have choice 3. I'm going to try 3 pi over 2. Sine of 3 pi over 2 is negative 1. Cosine of 3 pi over 2 is 0. Add those up, we get negative 1. That works. So it looks like choices 2 and 3 both work. That leaves us with choice D. I love this problem. It's a little tricky, but it illustrates the difference between square root of infinity squared versus negative infinity squared. There are a couple little differences here, so let's take a look at this as two separate problems. Once we get our answers to those two separate problems, we can find our final answer. So, as I'm looking at this first problem, I notice that what matters on top is easy, 3x. What matters on bottom is 4x squared, but it's not 4x squared, it's the square root of 4x squared. So let's take a look at what that's really going to show us. 3x is just 3x. 4x squared, square root of 4 is 2. Square root of x squared is x. We have to be careful that that x stays positive, though, because when you square any number, like in 4x squared, squaring a number gives you a positive number. So when you take the square of that positive number, you get a positive number, even if x happens to be negative. That's not going to be a big deal on problem 1, but it is going to be a big problem on problem 2. Let's take a look at that again. Let's go as x approaches negative infinity. We're still going to get the 3x over 2 absolute value of x. Now take a look at the difference here. As x approaches infinity in problem 1, the x and the absolute value of x pretty much cancel each other out, and they're both positive. X is positive and absolute value of x is positive, since we're choosing very large positive numbers for x. So those x's cancel out and we just get 3 over 2. Problem 2 is the tricky one. The x's kind of cancel out again, except as x gets close to a big, big negative, the top is going to be a big negative, the bottom is going to be a big positive. Positive over negative becomes a negative. So those two limits are not exactly the same. But once we figure them out, we can go 3 over 2 minus negative 3 over 2. 0 is a great distractor, but it's not right. We end up with 6 over 2, which is equal to 3. That's probably one of the trickier problems. I highly recommend that you jump on Desmos and graph this function, and you'll see exactly what's going on. If you want to go on Desmos, you can graph y equals 3x over square root of 4x squared plus x plus 6. You'll see both of these horizontal asymptotes on that graph. This problem is probably the messiest algebra out of all 6 of these so far. If we take a look at this problem, we're told that the limit as x approaches 3 has 2 possible values, a and b. If that's going to have 2 possible values, that makes me think there's 2 different values for k. It turns out that is the case. So let's take a look. If we plug in limit as x approaches 3 from the left, that means we're going to use the bottom equation. Plug in 3, I get k squared minus 3 squared. If I look at my limit as x approaches 3 from the right, I'm going to be looking at the top part of the equation. It looks like I'll get 5k minus 3. Now, since the left and the right have to be equal, because the limit does exist, we're going to say k squared minus 9 equals 5k minus 3. Now we've got to solve for k. So I'm going to get all of the terms on one side first, set that equal to 0. It's like we get k minus 6, k plus 1 equals 0. Now, this answer is not here, but I think a great distractor would be positive 5. Because it's telling you to find the sum of a and b. And if you accidentally think that's your a and b, you would add those up and get 5. However, those are the values of k. So we've got to go back and rewrite the function. There's going to be 2 different ways to write this function. The first way is to put k in as 6. So instead of 5k, we get 30 minus x, when x is bigger than or equal to 3. And we get 36 minus x squared when x is less than 3. Now, if we plug x equals 3 into both of those, top we get 27, bottom we get 36 minus 9, which is also 27. So it looks like one of our answers is 27. Well, left and right matched. We still have to figure out b, and we still have to add those 2 together. So taking a look at that, I'm going to put in my negative 1 in place of k. 5k becomes negative 5 minus x. And x is bigger than or equal to 3. K squared is going to give me 1 minus x squared for when x is less than 3. Now I can go ahead and plug in 3 again, since I'm trying to find the limit as x approaches 3. On the left, it looks like I get negative 8. On the right, it looks like I get negative 8 also. Since those match, I can feel confident that my b is negative 8. Notice both of these answers were up there as distractors, but it's asking us to find a plus b. So if we go 27 plus negative 8, we get 19. So C is our correct answer. That one was tough. Good luck and stay savvy, my Padawans.